Yes, good morning, class. In the previous lecture, we have covered recursive, enumerable, and recursive languages. Good morning, Raki and Siddhant. And recursive, enumerable, and recursive, the difference is if any language is recursive, if Turing machine accepts it and halt on any input, as I already told you. So the meaning is simple that suppose this is the Turing machine, the definition can be represented clearly with the help of the diagram. If M is the Turing machine and W is the string that passed to the Turing machine. So after execution, Turing machine finalize the decision whether it is accepted or it is rejected, and after that your machine will reach to the halt state. So this is the simple purpose of the recursive languages. Then you can say this language is the recursive language. Means if we pass any string, then definitely you will get the answer in the form of yes or no, right? And machine will get automatically halt. This is the simple representation for recursive languages. Now, what about the recursive enumerable? So if we talk about the recursive enumerable, then your machine can get machine will accept if W belongs to that machine or belongs to L, that machine will accept the language, or if it is not belongs to the language, then it may reject. But the important point here is there may be loop forever, or your machine, it is not guaranteed then your machine will halt after the completing the process. So it is looping or loop forever in case of the recursive enumerable. Means we can say in case of recursive enumerable, if the language is accepted, then it is possible, then it is accept plus halt. Otherwise, if this is the case of rejection, then in case of the rejection, it is not guaranteed that you will find the solution. You may be in the loop. So this is the basic difference between these two definitions. Now we will discuss some properties, and these properties are called decision properties. So these properties are related to the recursive and recursive enumerable. So the decision properties are: number one is the union. Number two is the intersection. So recursive languages are closed. Just you can note down this thing. This is very important point. So recursive languages are closed under union, under intersection, and under complementation. Right? So recursive languages are closed under union, under intersection, or under complementation. Right? But if we talk about the recursive enumerable, then recursive enumerable languages are not closed under under complementation. Means this is the recursive, and if we talk about the recursive enumerable languages, it is closed under union and under number two under intersection only. Right? Means recursive enumerable languages are not closed under complementation, while recursive languages are closed under complementation. So these are called the basic properties or the decision properties of recursive and recursive enumerable. Clear? So as we already completed the syllabus, so we already completed the basic definition of recursive enumerable. So now we can prove the complementation part. So suppose any question is given to you that in that case, suppose, just see here, in that case, it is given to you that any language is recursive, then you have to prove that the complement of this L should be recursive. So we know with the closure property of or the decision property of this recursive languages that the complement of recursive language L is also recursive. So just here how. So if suppose this is the this is your machine, and this is the W, a string that you pass to that machine. After that, if it is recursive, then definitely you will get the answer in the form of accept or reject, right? And your machine will get halt. Is it clear? This is the simple representation for recursive. Now, if we do the complementation, that means in case of complementation means just we are, this is the another machine M dash, this is the complement of M. So if this is the case of accept, it will convert it into reject, and reject case is converted into accept because it is the complement, right? And after that, your machine will get halt. So finally, you will get the answer in the form of accept or reject, and your machine will get halt. So simply means if we have a recursive language, then the complement of recursive language is also recursive. Is it clear? So you don't need to prove this type of theorem, but you should know the decision property that the union, intersection, and the complementation is recursive, right? So now, this is mathematically, I already told you this thing that L be a recursive language and M is the Turing machine that accepts it. So for W string, if W belongs to L, then M halts in a final state. If W does not belongs to L, that means M halt on non-final state. So it is compulsory that you will get the answer in the form of accept or in the form of reject in case of recursive languages, and machine will get halt. But these are the remarkable points that we should keep in mind, that a problem or language with two answers means if we have any problem in the form, if we have the answer or solution of any problem in the form of yes or no, then this type of problems are called decidable or solvable problem. Or in the other words, we can say if we have a procedure or algorithm to find the answer of any problem in the form of yes or no, then such type of problems are called decidable problems, right? So another one, if a problem or language is undecidable, that means it is not decidable, right? So this is the definition for decidable, undecidable, solvable, and unsolvable problem. Now another definition that I already told you about the recursive enumerable. So a language is recursively enumerable if some Turing machine accepts it. Just note down here, means this recursive enumerable languages are ensuring the case of accepting, but not, it is not guaranteed that if any language that is not belongs to that that W is not belongs to that language, then it will be rejected. It is not guarantee in case of recursive enumerable. But in case of recursive, it is guarantee. If it is belongs, then accept. If it is not belongs, that means reject. So only acceptable cases in recursive enumerable. Now the important point is, if L is recursively enumerable and M is the Turing machine, then for W string, if W belongs to L, that then M halt in a final state. If W does not belongs to L, then M halt in a non-final state or loop forward. So this is the important part here. Means if the case of rejection is not assure you, means if any string does not belongs to language, that means it is not guaranteed that you will get the answer. You can move, you can reach to the loop also, right? So this is the simple difference between recursive and recursive enumerable. And one more point that I want to discuss with you about the complexity. So basic definition about the complexity and computability, just you can see here. And what is the meaning of complexity? So the simple, the definition of complexity can be a formal measure that how efficient or algorithm or program is. So simply it is called the complexity. Suppose just I am going to discuss one answer, one question actually, one problem. Suppose this is the data, right? This is your data. 45, 8, 9, 63, right? So suppose you have to sort this particular given data, right? So the process is you can use any algorithm. Suppose we use one algorithm and that algo sort this data in one step, right? Any another algorithm that will sort this data in three steps, right? Or three passes, you can say. and one more algorithm that can use only 5 steps. So you directly, by seeing this statement, you can directly say that first algorithm is better because it is less complex. So complexity depends on two parameters. First one is the time and second one is the space. So on the basis of these parameters, we can say that particular problem is complex or particular problem is simple. So that means a formal measurement or measure how efficient or algorithm or program is simply referred as the complexity. This is the simple term that you already studied in DA, so you know very well. So this is the basic definition for the complexity. And now what is the computability? So just see here, a formal and intuitive description of computation means how can we compute the process of going to compute any function is simply referred as the computability. So you should know about the basic definition of computability and complexity. So this is the about the complexity and computability. Now, what about the complexity class? So a complexity class is nothing. It is just the collection of problems which can be solved by some computational model. So simply you can directly say that complexity class is how the complexity class is differ from the complexity. So simply if I talk about the complexity, then complexity is the measurement, how efficient your program is. But if we talk about the complexity class, that means it is simply the collection of problems which can be solved by some computational model. So this is the complexity class. So there are lots of complexity classes that you already read in case of subject DA. So complexity class P, complexity class NP, complexity class of NP hard and NP complete. So आपको बहुत ज़्यादा डिटेल में जाने की जरूरत नहीं है, but you should know the example of each class. ये आपको जरूर और हर एक की definition आपको याद रखनी चाहिए. So P complexity class P is what? So complexity class P is defined to be the set of problems solved by the Turing machine in polynomial time. So here the term polynomial time is time means the time is decidable time. Means if we solve any problem in a polynomial time or the desirable time or the expected time, then this type of problem is called class P problem. And these are the various examples related to the complexity class P. That is the postman problem, searching shortest path, and searching the matching. So this is all about the complexity class. अब आप NP hard, NP complete ये definition जो आपने डा में पढ़ी है, आप उन definitions को याद कर सकते हो. You can mark them. ठीक है, उनकी definition आपको याद रखनी है. Now अब हम लोग थोड़ा सा आगे चलते हैं. अब कोर्स हमारा कवर हो गया, तो अब कोर्स कवर होने के बाद हम लोग कोई अगर टाइम कॉम्प्लेक्सिटी की बात कहता है तो हम लोगों को पता है कि जैसा हमने आपको बताया कि मिनिमम टाइम में किसी चीज को हम सॉल्व कर सकते हैं, दैट इज द बेस्ट, एंड मैक्सिमम टाइम में सॉल्व करेंगे, दैट इज द वर्स्ट. तो देयर आर टू केसेस, बेस्ट केस, वर्स्ट केस इन विद रिस्पेक्ट टू द टाइम. So now I would like to discuss some questions that can be asked on the basis of recursive and recursive enumerable. So just see all these questions. In this case, just see the questions. Suppose just start with the recursive. This is the, so as I already told you the basic property of recursive and recursive enumerable, that recursive languages are close under union, intersection, and the complementation, while recursive enumerable languages are not close with the complementation, right? So just you can see here the question, recursively enumerable languages, that is RE languages. If anyone asks you in this format that RE languages, RE means recursive enumerable languages, are not close under complementation, union, intersection, and none of these. That means if it is recursive there, suppose enumerable is not there, so in this case complementation, union, intersection, recursive languages are close in all the cases. But if we talk about the recursive enumerable, then especially in case of recursive enumerable, it is not closed under complementation. I already told you. So just read all the closure properties of the recursive and recursive enumerable languages in detail. right? Another one is which of the following statement is wrong. So the same, I am going to discuss one important point. The same question can be asked you in different manner, in different way. So you should know about the basic concept of these topics, right? So another one is which of the following statement is wrong. Just you have to find out. Every recursive language is recursively enumerable, right? uh, every recursive language is recursively enumerable. The next one is a language is accepted by finite automata if it is only if it is context free. Means in case of finite automata, the language should be context free. No, not at all. So this statement is wrong. अब अगर मैं इसकी बात कर रहा हूँ कि रिकर्सिव लैंग्वेज है, वो रिकर्सिव इन्यूमरेबल होगी, ऑब्वियस सी बात है। ये हमारी रिकर्सिव के इन्यूमरेबल के केस में क्या था कि रिकर्सिव इन्यूमरेबल के केस में आपका जो आंसर है वो हमेशा क्या होगा, यस या नो की फॉर्मेट में होगा, है ना, हमेशा। और रिकर्सिव इन्यूमरेबल में क्या होगा, यस होगा, नो की कोई गारंटी नहीं है। तो एवरी रिकर्सिव लैंग्वेज इज रिकर्सिव इन्यूमरेबल। So this statement is true. Third one is recursive languages are closed under intersection. I already told you recursive languages are closed under union, intersection, and complementation. And finally, last one is a language is accepted by finite automata if it is right linear. Yes, if right linear languages are accepted by the finite automata. Means type 3 languages, that is regular language. So this is on the basis of these statement, anyone can ask you multiple questions, right? तो आपको सारे क्वेश्चंस इस तरीके के ध्यान में रखने होंगे, सारी प्रॉपर्टीज आपको इस तरीके से ध्यान में रखनी है। And one more question is, if any Chomsky normal form is given to you and you have to derive a terminal string of length n, then number of steps or number of productions should be used. So always with the help of the tree property, you have to require 2n minus 1 production to produce the string, terminal string of length n. Another one is which of the following is true, means on the basis of this question, just here is which of the following statement is wrong. So on the basis of these points, just I am giving you one more question that will help you to discuss on recursive and recursive enumeration. Just see here. Which of the following is true? The complement of recursive language is recursive. Yes, this is obviously true. I already told you that the complement of recursive is recursive, recursive language is recursive, union is recursive, intersection is right. Another one is the complement of recursive enumerable is recursively enumerable. It is not sure, it is not guaranteed, it is not possible. The complement of recursive language is either recursive or recursive enumerable. No, not at all. Complement of recursive is always recursive. तो ये भी आपका false हो गया, गलत हो गया, wrong हो गया. The complement of context free is context free. In the complement of context free, context free का जो complement होगा वो context free नहीं होता, है ना? So this is also the wrong answer. So the point of communication is you should know that point, that on the basis of these points I can ask you many questions. So you should know the basic property of recursive, recursive enumerable, and the context free. Another one is if there exists a language L for which there exists a Turing machine, right? So T that accept every word in L and either reject or loop for every word. So which is related to when L is called what? Recursive, recursive enumerable, NP hard, none of these. So whenever you find the situation of loop, then directly you should mark the recursively enumerable, because the case of loop is applicable only in case of recursively enumerable. Okay, so this is, I already told you that accept, reject plus loop forever. So this is the property of recursive enumerable. Another one is related with the universal Turing machine. So if universal Turing machine influence the concept of, just see here, in case of the universal Turing machine, we use three different tapes. One is store the program, another one is store the inputs, another one is store the states, right? Description, states, and program. So universal consists of these three tapes. I already discussed this in at the time of discussing the universal Turing machine UTM. So just see here, universal Turing machine influence the concept of what? First is the stored program computers, another one the interpretative implementation of programming language, and third one is the computability. Computability means finite control wala kaam. So all these are work done by the universal Turing machine. So the answer is all of the above. So just you should keep go through all these points and you should know about these properties. Another one is which of the following statement is true. देखिए मैं अभी तक केवल आपको उन्हीं प्रॉपर्टी को घुमा के पूछ रहा हूँ, है ना. मैंने क्या कहा आपसे कि ये इसका यूनियन है, ये इसका इंटरसेक्शन है, ये इसका कॉम्प्लीमेंट है. बस इसका कॉम्प्लीमेंट यूनियन का, रिकर्सिव का, रिकर्सिव इन्यूमरेबल का. तो आप सिर्फ ये ध्यान रखना है बेसिक प्रॉपर्टी और उन्हीं के बेसिस पर इनको पढ़ना है. जस्ट हियर रिकर्सिव लैंग्वेजेस आर क्लोज अंडर कॉम्प्लीमेंटेशन. कौन सा स्टेटमेंट इसमें सही है? एक से ज्यादा भी सही हो सकता है ना. तो अब आप देखिए रिकर्सिव लैंग्वेजेस आर क्लोज अंडर कॉम्प्लीमेंटेशन हम लोगों को पता है, लेकिन रिकर्सिव इन्यूमरेबल नहीं होता, राइट. अब देखिए रिकर्सिवली इन्यूमरेबल लैंग्वेजेस आर क्लोज अंडर यूनियन. मैंने क्या बताया था? रिकर्सिव इन्यूमरेबल लैंग्वेजेस आर क्लोज अंडर यूनियन एंड इंटरसेक्शन बट नॉट कॉम्प्लीमेंटेशन, राइट. तो ये दोनों स्टेटमेंट सही है. नाउ थर्ड वन, रिकर्सिवली इन्यूमरेबल लैंग्वेज आर क्लोज अंडर कॉम्प्लीमेंटेशन. नो, नॉट एट ऑल, बिकॉज I already told you that recursive enumerable are not closed under complementation. So these two statements are correct, one and second. Clear? So just my point of communication is the same question can be asked you by multiple ways. तो आप इसके लिए नेट पर क्वेश्चन मल्टीपल चॉइस क्वेश्चंस देख सकते हैं और उनको अटेम्प्ट कर सकते हैं. क्विज जो ऑनलाइन क्विज होती हैं और उनके बेसिस पर आप अपनी प्रैक्टिस कर सकते हैं. ठीक है. नाउ this question, type 0 grammar is accepted by Turing machine, PDA, LBA and DFA. So for this grammar and the automation, I would like to discuss the Chomsky classification. If your grammar is type 2 grammar, then this grammar is accepted by finite automata, right? We have already discussed in detail in case of the Chomsky classification. So if it is type, sorry, extremely sorry, it is wrongly posted here. This is type 3, right? Finite automata. If I talk about type 2 grammar, it is accepted by PDA, push down automata. If I talk about type 1 grammar, then it is accepted by linear bounded automata, that is LBA. If I talk about type 0 grammar, and that grammar is called recursive grammar, recursive language you can say, and that is accepted by Turing machine. So just see here, type 0 grammar is accepted by Turing machine. जब मैं इसका साइन भी चेंज कर लेता हूँ, कलर चेंज कर लेता हूँ. So this type 0 grammar is accepted by Turing machine. Type 1 grammar is accepted by LBA, linear bounded automata, right? And type 2 grammar is accepted by PDA, and type 3 grammar is accepted by finite automata. So always you should keep in mind these points to learn Chomsky classification better. ठीक है, ये समझ में आ गई बात. तो अब वापस से क्या करते हैं, अब आपसे यही क्वेश्चन मैं पूछता हूँ कि टाइप 0 ग्रामर इज एक्सेप्टेड बाय व्हाट. तो जस्ट ट्यूरिंग मशीन, जस्ट यू कैन सी दिस डायग्राम एंड जस्ट राइट द आंसर. टाइप 1 अगर आपसे कोई पूछता है, यू शुड नो अबाउट दैट टाइप 1 ग्रामर इज एक्सेप्टेड बाय LBA. और टाइप 2, तो स्पेशली अगर मैं आपसे बात करूं तो टाइप 2 और टाइप 0 की कर सकता हूं, बिकॉज दीज 2 ग्रामर आर इन आर सिलेबस. और एक और इम्पोर्टेंट बात है, इसमें हमारा फर्स्ट मॉड्यूल के भी कुछ क्वेश्चंस आएंगे, तो अगर आपको फर्स्ट मॉड्यूल में भी कोई डाउट लगता है तो हम उसको भी रिवाइज कर सकते हैं. तो मेरी तरफ से सब कुछ कंप्लीट हुआ. अब आप बताइए, आपको कोई कंफ्यूजन है किसी पॉइंट पर तो प्लीज आप लोग जरूर डिस्कस करें, है ना. हम लोग कल क्विज करेंगे, इसी के बेसिस पर आप लोग नेट से क्वेश्चन देख सकते हैं, तो उससे आपको एक ये पता लगेगा कि किस तरीके से क्वेश्चन पूछे जा सकते हैं. हम लोगों ने कंस्ट्रक्शन बहुत सारे किए हैं क्वेश्चन, हम लोगों ने बहुत सारी लैंग्वेज के क्वेश्चंस किए हैं, सिंप्लीफिकेशन के क्वेश्चंस किए हैं. तो हम लोगों को थोड़ा फास्ट करना होगा एग्जाम में, क्योंकि एग्जाम में सर्टेन टाइम फिक्स होगा, एक क्वेश्चन के लिए पर्टिकुलर टाइम फिक्स होगा. So you have to solve the question in the given time or a given particular time. अब आपकी तरफ से कोई डाउट है तो प्लीज आप लोग पहले डाउट पूछिए, कोई टॉपिक ऐसा हो जो समझ में नहीं आया हो तो मैं आपको वो टॉपिक बता सकता हूँ। मैंने अभी अपनी तरफ से ये सारी चीजें आपसे डिस्कस कर ली, सारी चीजें आपको बता दी कि किस तरीके से इनकी स्लाइड्स मैं आपको प्रोवाइड कर दूंगा, और इनमें बहुत ज्यादा आगे पढ़ने की जरूरत नहीं है। जस्ट जितना मैंने आपको पढ़ाया है, मैंने आपको सारा सिलेबस कंप्लीट कराया है, एक एक पॉइंट। तो किसी पॉइंट में भी अगर आपको लगता है कि सर ये थोड़ा कम समझ में आया, आई विल एक्सप्लेन अगेन, ठीक है। इसमें कॉम्प्लेक्सिटी क्लास में जस्ट हमारे सिलेबस में लिखा है इंट्रोडक्शन टू कॉम्प्लेक्सिटी क्लास। That means you should know the basic definition of complexity about the and along with the complexity class, means P class, NP, NP hard and NP complete. Nothing else. Recursive enumerable we have completed. Halting problem of Turing machine. Halting problem of Turing machine is undecidable problem or unsolvable problem. हाँ बेटा मनी मैं कर दूंगा, ये मैं कर दूंगा, आपको अपलोड कर दूंगा, मोस्ट प्रोबेबली आज ही कर दूंगा, ठीक है। So halting problem means terminating, and this problem is called undecidable problem. So is there an algorithm to decide whether machine halt on input W or not? So this problem is simply referred as the halting problem of Turing machine. And then universal Turing machine. Universal Turing machine means just we have to pass the description in the form of M comma W, where M is the Turing machine and W is the string. Or in the same thing can be called in that way that we have to require two components, a program or machine, and second one is the string or the data set to for the program to process. And this machine is developed by Alan Turing, means proposed by Alan Turing in 1936 in his research paper, and title was Universal Computing Machine. Clear? So anyone ask you about write the short note on Universal Turing Machine, because this type of question can be asked in short answer type question. So you should write that it consists of two components, that is the program and data, or you can say that is the M and W. Where M is what? It takes the machine will execute the program, execute the given string and give the output. और ये program और data set क्या होगा? That is passed to the machine. So this is all about the universal Turing machine. And after that, Church Turing thesis we have already completed. So Alan Church proposed his thesis in 1930, and the common interpretation of the thesis was every algorithmically computable function is Turing machine computable. And second interpretation was a function is computable if and only if it can be solved by the Turing machine. So these are two main interpretations of Church Turing thesis. And the detailed statement, you can also say that Turing machine is a general model of computation. It is simply to say that any algorithmic procedure that can be carried out by at all, means by the human, by the group of human, or by the computer, can be carried out by the Turing machine. Means Turing machine will be the so powerful that can do all the work that can be done with the help of the human. So this basic statement is given or formulated by Alan Church in 1930, right? Means before invention of the Turing machine. But why it is not called theorem? It is called thesis or the hypothesis, because it is there is no precise definition of the term algorithmic procedure. Means we can't prove this statement mathematically. That's why it is called the hypothesis, right? So this is about the Church Turing thesis. And then these are the variants of Turing machine, different variants. Under this we have already read the Turing machine with stay option, multi-tape Turing machine, multi-head Turing machine, multi-track Turing machine, right? So we have already non-deterministic Turing machine, all the semi-infinite Turing machine, offline Turing machine, and eighth one, you can also write the universal Turing machine. So all these can be considered as the variants of Turing machine in detail. So if anyone asks you write the name of any 7 variants of Turing machine, then you are able to write the name. If anyone asks you write the transition function for multi-tape Turing machine, multi-track Turing machine, then easily you can write the transition function for the same. And these are the more questions about the construction I will give you. In case of I will provide you. This is the Turing machine for fn equals to 2n. तो अब आपके एग्जाम में इस तरह से कंस्ट्रक्शन ऑफ मशीन तो नहीं आ सकता, बट ऐसा हो सकता है हम आपको मशीन दे दें और आपसे इस मशीन के बेसिस पर कोई स्ट्रिंग दें और आपको चेक करके बताना होगा वेदर दिस स्ट्रिंग इज एक्सेप्टेड बाय दिस मशीन और नॉट। ठीक है, तो कंस्ट्रक्शन पार्ट हम लोगों ने कवर किया था, जिसमें हम लोगों ने fx प्लस y भी किया था, 2's कॉम्प्लीमेंट किया, 1's कॉम्प्लीमेंट किया, w रिवर्स किया, an bn cn किया, equal number of a's and equal number of b's, then a and bn and Turing machine recognize w where w end with a. So we have completed all the construction, all the questions, maximum questions, and this is the basic definition of the Turing machine. That is given by this. These are the 7 tuples. Similar to the finite automata, these 2 tuples are additionally used in case of the Turing machine. First one is the tau and another one is the blank. These 2 tuples are additionally used in case of Turing machine. In case of the finite automata, we use 5 tuples, but here we use 7 tuples. So this is all about the Turing machine. सेट ऑफ स्टेट लिखने मैं समझा नहीं बेटा। सोनल आपका क्वेश्चन नहीं समझ आया? सोनल आपका क्वेश्चन मेरी समझ में अभी नहीं आया बेटा। आप बोल सकते हो, मैं आपको अलाउ कर देता हूँ सोनल, जस्ट ए मिनट। यस सोनल बोलिए, आप बोल सकते हो बेटा सोनल।
सर वो किसी क्वेश्चन में सेट ऑफ स्टेट भी लिखने के लिए आ सकता है ना, वो पूछ रही थी।
हाँ आ सकता है बेटा, आ सकता है।
ओके,
वो भी लिखने के लिए आ सकता है ना। और एक और इम्पोर्टेंट पॉइंट याद रखना है कि अगर हम कोई भी मशीन आपको बनी हुई देते हैं, है ना, और आपसे पूछते हैं कि चेक वेदर दिस पर्टिकुलर गिवन स्ट्रिंग एक्सेप्टेड बाय दिस मशीन और नॉट, then in this case the blank sign can be represented by hash sign or by blank sign. Normally these two signs are used. तो आपको देखना होगा कि ऐसा नहीं है अगर ब्लैंक नहीं है तो आपको लगे कि ब्लैंक इसमें क्यों नहीं है। In place of blank it may be possible that hash sign will be used. So just try or check in the given problem. ठीक है, so this is all about the Turing machine portion. ये हम लोगों ने ट्यूरिंग मशीन के अंदर में सारी चीजें कवर की थी। इससे पहले हम लोगों ने क्या पढ़ा? पीडीए से ग्रामर, ग्रामर से पीडीए, तो कल हम लोग रिवाइज भी कर लेंगे। इससे पहले वाला पार्ट नॉर्मली हम लोगों ने क्या क्या पढ़ा है डेरिवेशन ट्री से लेके, और बाकी एक क्विज अरेंज कराएंगे कल। ठीक है, तो आप लोग प्रिपेयर रहिए, और सबसे अच्छी तरीका है आप नेट से, इंटरनेट से आप ऑनलाइन क्विज अटेम्प्ट कर सकते हैं और आपको उससे पता लगेगा आपकी प्रिपरेशन कैसी है। ठीक है, तो और कंस्ट्रक्शन में बहुत ज्यादा टाइम देने की जरूरत इसलिए नहीं है क्योंकि कंस्ट्रक्शन एग्जाम में नहीं पूछा जा सकता, राइट? वैसे पूछा जाता अगर आपका एग्जाम सब्जेक्टिव होता, बट अगर ऑनलाइन की बात करते हैं हम तो ऑनलाइन में कंस्ट्रक्शन नहीं पूछा जा सकता क्योंकि आप कैसे डिजाइन करोगे मशीन। ठीक है ना, तो बस उसका हम आपको चेक इस तरह करेंगे कि मशीन देने के बाद हम आपसे उसका इंस्टेंटेनियस डिस्क्रिप्शन पूछ सकते हैं या हम उसका आपसे एक्सेप्टेबिलिटी या रिजेक्टेबिलिटी पूछ सकते हैं। ठीक है, so if you have any doubt or any problem please let me know. कोई भी डाउट हो बेटा पूछ सकते हैं आप लोग। ठीक है, तो तैयारी रखें, ये मैं स्लाइड शेयर कर दूंगा आपके साथ स्टडी मटेरियल पूरा, और वीडियो लेक्चर्स भी अपलोड कर दूंगा करंट वाले, अगर कुछ आपको चाहिए होंगे तो आप देख सकते हैं उनको। और किसी भी तरह का कोई कंफ्यूजन है, कोई डाउट है तो आप मुझे जरूर बताएं, कल हम लोग इसको डिस्कस करें। थैंक यू फॉर अटेंडिंग द क्लास।